Hi. So I'm Mr. Gustafson. I am the one of the science teachers here at Pinyon High School, and we're doing a little demonstration of one of the lessons that the students learn in chemistry. That's why I'm wearing a lab coat because it's the chemistry class. We're doing one of the lessons that the students learn, and we're doing a demonstration afterwards on a separate video, an experiment that the students, if they were in the building, they would do the experiment. Now, one of the things that we learn in the chemistry class is not only the elements, all of the periodic table of the elements, we learn how to read the periodic table. What does the atomic number mean? What does the atomic mass mean, etc.? What group number are certain elements in? What are certain special fancy names for certain elements? We learn all of these things, groups of elements, etc. And we learn about the bonds that those elements make. For example, you could have an oxygen atom floating around, and you could have two hydrogen. My finger and thumb represent the hydrogens. This ball is the oxygen, and this fist. And you can have two hydrogens, and when they come together, because they bond in a certain way, you'll have two hydrogens, H2O. Two hydrogens and one oxygen, H2O. And what do we know H2O to be? Of course, water. So molecules are built up by combining atoms together. Atoms are the elements, and molecules are combinations of the elements. And so the types of bonds, there's three types of bonds. There are ionic bonds, there are covalent bonds, and there are metallic bonds. Now, metallic bonds are things like how you build a chunk of iron, for example, out of iron atoms, and they bond a certain way. Meanwhile, covalent bonds bond a certain way as well. Those are, as the name suggests, covalent. Those are elements that share valence electrons. I don't want to go too deep on this. The students are learning this stuff. So you could ask your students, what's a valence electron? What's the valence orbit? What's a covalent bond? And there's a good chance that the students will know the answer. So that's one of the types of bonds, covalent bonds. H2O, water, is a covalent bond. And the third type, it was the first that I mentioned, are ionic bonds. And these are bonds where the elements create ions, and the ions come together and bond a certain way. What happens is, let's go to our boy, the periodic table. Here is, I don't know, we'll call it, right? Where's my finger? There it is. This is chlorine. You can barely see the Cl. The Cl in kind of orange letter there. That's chlorine. Look, the name says chlorine. Yay. And it's number 17 on the chart, and it's in group 7. It says 17, but we only consider the ones digit. So it's in group 7. It's number 17. It has a certain atomic mass. If I get real close, you'll see that's 35.4, blah, blah, blah. Okay. Meanwhile, way over here on the other end of the chart, easier to read, here's sodium. Na is sodium. See the word sodium? And you see that it has a certain mass, looks to be about 22 and change. Here it's number 11 on the chart. It's in group 1, and that matters later on. So sodium is in group 1, chlorine is in group 7. And when we combine the two, we have an ion that has +1 of a charge, and we have an ion that has -1 of a charge. Let's not worry about how that happens. Ask your student. Perhaps they'll be able to give you a lesson. So sodium, when it forms an ion, the atom is just plain old sodium atom. But if it forms an ion, that means an electron has flown away. Too much energy, got lost. Sodium is without an energy, so it'll have a +1 charge. Meanwhile, chlorine over on the other end of the chart, this one's chlorine. Chlorine is going to have an extra electron, so it'll have a -1 charge. And when we have 7, which is -1, and when we have 1, +1, Combine the 7 and the 1, we get 8, which is the magic number. All of nature loves to have 8. There's something called the octet rule, which nature requires that for elements to be stable, for compounds to be stable, they fill their valence orbit with 8 electrons. So 7 from chlorine, 1 from sodium, that's 8. That's a full octet. Yay. Or we could say sodium has a charge of +1, chlorine has a charge of -1, -1 plus +1, add the two together, you get 0, which is a neutral atom, or in this case, a neutral molecule, which is what we want, neutral. So, okay, I've been talking about sodium chloride forever, right? Sodium and chlorine, and creates sodium chloride. Think for a minute, can you tell me, I know you're on a video, so you have to tell yourself, but can you tell me what sodium chloride is? What do we know that as at home? Common household item. The answer is salt. Sodium chloride, NaCl. Sodium chloride is salt. And what we're going to do, salt, by the way, forms an ionic bond. And what we're going to do in the demonstration, which is on the video you'll see in just a minute, what we're going to do in the demonstration is we're going to show that salt and maybe some other household items are formed by ionic bonds. Some are not. Stay tuned for the demonstration. Enjoy that and have a great day. Thanks very much. Stay safe.
Yeah.
Started. Is the number counting down?
Counting up, yes.
Okay. Hi. So what we want to do is a demonstration of what happens in the science room, in this case particularly in the chemistry lab. We're going to do an experiment where we talk about ionic bonds. There are 3 kinds of bonds. There are ionic bonds, covalent bonds, and metallic bonds. And ionic bonds are the ones that we run into a lot with respect to food items. So we've got some items that are kind of food related here. Every one of these holds distilled water, and this one has vinegar, and this one has salt, and this one has sugar. You can't tell it's sugar, but it is. And this one has baking soda. So what we're going to do is we're going to use this battery apparatus and determine which of these is good at conducting electricity. We have some batteries here, so there's electricity. You can see that there's electricity. If I hold the light bulb here and I connect the leads to the light bulb, in just a second you'll see, hey, the batteries are working. The light bulb is on. So what we're going to do is we're going to mix up, we're going to stir up these items. They each have their own stir stick. So we're going to stir up these items. Okay, nice and blend in the materials. These all are holding distilled water plus whatever it is we put in there. Okay, let's stir up the sugar. Okay, it's stirring up pretty well. Not great, but pretty well. All right, let's stir up the salt. Salt is an ionic bond. It's sodium and chlorine. And when it forms an ionic bond, when it forms a salt molecule, it's called sodium chloride. That's your regular household la-di-da-di-da type of salt is sodium chloride. Okay, so here's what we want to do. We know that there's electricity flowing in the leads, so we want to take the leads and place them into the material and then wait for about a minute or so, and we'll come up and look and see if we've got bubbles forming on one of the leads. Okay, so here's the distilled water, and we can see inside, and it looks like there's the tiniest bit of bubbles. That bubbles indicate that electricity is flowing, and the more bubbles you have, the more electricity they have. Okay, so here's distilled water. Come on up, let's bring the camera up close and look inside real close to the distilled water. And what you're going to see, if it shows up at all, come on right up on top and look inside. What you're going to see is on the leads, there may or may not be tiny bubbles. Get real close, right up on top of that. Yeah. So this one looks like it's pretty thin, not conducting the electricity very well. That's distilled water. Let's go to the vinegar. Distilled water, no. Let's go to the vinegar, give that a minute, and then we'll take a look at that guy. We don't care about the water and electricity. They're going to blend or anything like that. That's not going to happen because this is a controlled scenario. Okay? So if we look real close after a bit, go ahead and get on closer in there. You can see that there's not a whole lot going on bubble-wise. Vinegar is a no also. So water is not an ionic bond, and vinegar is not an ionic bond. Here's salt. Now, salt is one of the most famous ionic bonds. So let's see what happens here. Oh my goodness, look at that lead is spewing bubbles. So salt is definitely an ionic bond. It's conducting electricity. That's the key. Ionic bonds are good conductors of electricity. So we saw nothing in the vinegar, nothing in the water plane, but look at the salt. Boy, that's going crazy. So that's definitely an ionic bond, the salt. Okay, let's try the sugar. Let's see if the sugar forms any kind of ionic bonds. Will we get any bubbles flowing out of here? Let's find out. So we'll go ahead and look. We got the leads are inside there, and if we look down close, we're seeing nothing really. It looks pretty dead. So I'm going to say sugar, no. And last but not least, baking soda. Let's try baking soda. Let's see how that turns out. So baking soda, same story as the salt. Not surprising because it is an ionic bond. Baking soda, same story as the salt, spewing out the bubbles. So, of our choices, we've learned that baking soda and salt are ionic bonds. Sugar water, vinegar, and plain distilled water are not ionic bonds. Now, just to be sure, let's go ahead and get the camera on this next little test. Just to be sure that we didn't burn out the water or anything like that, or burn out the batteries, let's do another quick test with the lamp and make sure that we still have juice flowing. Of course, the last one had juice flowing, the baking soda. And look at that, the lamp comes, well, hang on, Dad. There we go. Look at that, the lamp comes on. So sure enough, we still have power in the batteries, and we saw baking soda showed conduction of electricity. Sugar water did not show conduction of electricity. Salt showed conduction of electricity. Vinegar did not, and plain water did not. So of the 5, if I were writing a lab report, I would say for this laboratory example, this experiment, salt and baking soda are ionic bonds. Sugar water, vinegar, and plain distilled water are not ionic bonds. And that's all there is to it. Hope you have a terrific day. Hope you enjoyed our little demonstration. Be safe. Thanks. Bye.